Okay, I think, okay. So, okay, so what we're gonna do is, okay, got it. Okay. So, okay, so we're just gonna do word problems because like, yeah, it's gonna like these questions are gonna be pretty much the same on the test you'll see on Saturday. So this question says a 100-meter long train accelerates uniformly from rest. Okay, so if the front of the train passes a railway worker 150 meters down the track at a velocity of 25 meters per second, what will be the speed of the last car as it passes the worker? Okay, so this question, so we'll start with actually drawing a kind of like a diagram of what's happening. So we have this train, just say here. Okay, so we know that um hmm, so 100 meters, okay, so 150 would be around here. So then that means an extra 100 meters makes that 250. So basically a 100-meter long train. So we know, let's say this is the train. And obviously it's not the scale, like I would like this is not 100 meters, obviously it's like, but so this is the train. Um okay. Um so I think this question's probably best broken down into like two parts. So we'll have in part one, and all you're using is like your kinematics formula, like the equations. So you'll have G, um, wait, what will be the speed of it? Okay, so G, then your initial velocity here is 0 because it's at rest. And then given required, oh, sorry, GRS is just like given required solution. It's like kind of like the short form of a grasp method. Like it's just structuring um like how to like organize like what's happening. I don't know. I think it's um anyway. So GR, I don't have to. You don't have to write this on your test order. You can just show your solution. Um. So the solution would be okay. We have acceleration is equal to v2 squared. Mm, over okay, yeah. Okay, so times it by 2d, but in this case, your b2 squared 2.08 meters per second squared. Okay, then part two, what we're trying to look for is the speed of the last car as it passes the worker. So, okay, so we gotta do, oh, okay, so we gotta do B1 is equal to 25 meters per second. And then this covers a distance of what? 100 meters, right? So your change in distance is only going to be 100 meters. And then at that acceleration, which is 2.8 meters per second squared. Okay, and then ooh, wait, let's put sorry. So yeah, we have B1, 25 meters, D is 100 meters, and then A is 2.08 meters per second squared. Okay. And then in this case, we're trying to find B2. So that's just the simple, well, again, yeah, it's B2 and then mm, okay. And then this one solution would be B2 equal to square root of B1 squared plus 2AD. And then you just plug in the numbers from the top. So you'll have 25 squared, which is 50, plus 2 times 2.08, which is like 4.08, times it by 100, which is like 408. So 408 plus 50 is about like 450, and then square root of that would be around 32.3 meters per second squared. Or just put 32. Okay. Um, okay. Stopping this. Okay. So yeah. So the whatever is highlighted and I guess they're encircled in blue is the like final answer, but then the green is like part one. Okay. Um. Okay. So next. So. Let me see a question. Boats over. Okay, projectile. I think we should do a projectile. Right. Okay. So let's do this one. Okay, so so this question is a projectile motion question. So you're gonna have I think it's good to just draw a diagram, but let's read it and see what it's asking us. So it says a rock is thrown horizontally at 10 meters per second from the top of a cliff, 122.5 meters high. Question part A asks, how long does the rock take to hit the ground? Part B says, what is the horizontal displacement of the rock? Part C says, what vertical velocity does the rock strike the ground with? And then part D says, what is the final velocity of the rock when it hits the ground? So, yeah, so in this case, what we have to do is, I think it's pretty straightforward here. So we'll have basically the diagram here that it says we have 120. Well, the cliff is 122.5 meters high. And then it's being launched at 10 meters per second. So here the initial here is 10 meters per second. So in this case, what we want to do is, and it's going to land like somewhere over here. Okay, and this is like the ground. Okay. Okay. So right. So part A says, how long does the rock take to hit the ground? So I think I'll give you guys, what is it, 123 right now? Okay, I'll give you guys 5 minutes to try and get an answer for A, B, C, and D. And then like yesterday, just send me a chat and then and I'll just note it down. So we'll connect back around 128. 128. Okay, let's see what we got. So in this case, what I'm going to use is the delta D is equal to V1T plus 1/2 AT squared. And then I just rearrange this one equation for everything that I'm gonna be solving for in the like A, B, C, and D. So we'll have this AT squared. Okay. So rearranging this one, we'll have time is equal to the square root of 2 times your distance over acceleration. So when you plug in the values, what you'll get is 5 seconds. Okay. Part B says, what is the horizontal displacement of the rock? So in this case, we're just going to use again, the same formula, but for solving for delta D. So we'll do delta D with the horizontal displacement is equal to velocity in the horizontal direction times time is equal to, and then when you plug in those numbers, you're going to get 50 meters. Okay, part C. What is the vertical velocity? What vertical velocity does a rock strike the ground with? You have V2 is equal to your square root of 2AD. And then you plug in those numbers and then you'll get 49 meters per second. Okay. Part D, we have what is the final velocity when the rock hits the ground? This one you just have to break it into the component vector. So you have 10 originally, and then you have the horizontal one, which is 49. And then the resultant is what's going to be the final velocity. So this vector right here. So do that. It's a squared plus b squared is equal to c squared. You should get 50 meters per second. Okay. Okay. Great. Okay. So so let me save this real quick. Show in folder, and then I'm just gonna upload it to the Google Classroom. So, okay. There, it's being uploaded. So, okay. So let's start on explaining what this lab thing is about. Okay. So basically what you guys are gonna want to do is actually yeah, great. Nice. Okay. So let's say okay. Here's the now let's make it lab report. Okay. Actually let's do kinematics. Okay. So it's gonna be due next Sunday. So Sunday is the basically the day after your test. So it's October 1st, actually. Sunday, October 1st, 23. Okay, so uh let's see. Okay, so uh uh yeah, I mean actually I'll just leave it. Okay, so this is what I'm expecting your uh paper to look like when you hand it in. So let's just say let's just say this is your it should just be one Word document. So let's just let's just set out the requirements now. So one Word document, single space, like you know, I mean, like um 12 font, you know, this is standard. So oh, okay. So yeah, one Word document, uh, basically single spaced. Um, and then basically what I want is so I want one hypothesis statement, one basically like introduction statement. So okay, introduction, and then oh yeah. So we start with the hypothesis statement, introduction statement. Then we want one basically uh like basically like a statement on like the experiment. So like explain so one so this is like the body of your lab report. So like what you want to do in this okay, one observation statement. Well, okay. So and then one conclusion statement. Okay. So pretty simple. It's not hard. Don't like I don't think you should overthink this one, but so the main I think the most important would be your observation statement because you're basically explaining what the experiment's doing, like what the experiment's about. And then um yeah, and then in your conclusion. So not what the experiment's about, but like the steps, procedures, materials, like all of that. Like include all of that in your observation statement. Your hypothesis statement should be like before you even before you even watch the video or the YouTube video, like you should have an I like just have an like have a prediction of what the like experiment's about. Then the introduction statement's obviously standard, like, okay, what is the experiment about? You usually find in like the first 5-10 minutes of the video. Um, and then yeah, the observation statement and then conclusion statement. So I think I'll actually just post the YouTube link in this document so you guys will have it. Um, okay, so right. Um, okay. Uh, okay. Okay. Does anyone have any questions? No? Okay, 1 second. Let me just upload this. Oh, okay.